Hi, welcome back. So far, we've been looking at the cyber kill chain, and we realized, of course, that the first step out of the cyber kill chain is to perform information gathering before actually going into the weaponization phase. So after arbitrarily performing information gathering, we have to go into the stage of weaponization. And the stage of weaponization, the idea is building a payload. And essentially, a payload is something that we're going to be creating, and then we're going to be shipping it off to the target. And this can either be an exploit or it can be a payload. An exploit, this is essentially a script that we write in order to take care of a certain vulnerability. Let's just say, for instance, we found that there's a vulnerability in some section of a program of some sort. Then we're just going to be writing a script that takes care of business. And then if it is a payload, then in this case, we'll be writing some malicious way to take care of everything. And what we're going to be looking at right now, we're going to be looking at a toolkit that comes with Kali Linux known as the Metasploit framework. So the Metasploit framework is made up of two parts. There's one known as Msfvenom and there's one known as MSF console. Msfvenom is used to build payloads, while MSF console is used to run exploits. So the whole analogy and the idea, if I grab my R node here to try and set it down to stone into a way that it makes a little more sense, is we're going to consider an arbitrary instance. For example, let's suppose we have a Windows system, for instance, and maybe this Windows system, let's just propose that this Windows system has a firewall. So we'll propose that there is some sort of a computer, and this computer has a program, firewall, and this firewall is pretty much there to block any remote access to it. So let's just propose this is a Windows system. It is made to be secure and all that. Thanks to the firewall, it has some antiviruses of some sort, and so on and so forth. So then we'll consider that there is me. I'm the malicious guy with the malicious intent. So after performing information gathering, I discovered that there are no open ports. Literally no open ports. So I will have to build a payload to go and make a hole in the firewall. That is the whole analogy and the whole idea. And remember, I have to perform information gathering first. Otherwise, I will not know what type of payload to make or what type of malware to make. After performing information gathering, I can maybe, per se, find out that the type of malware that I need is a malware for Windows. Then, that's going to be some useful information. So, by default, if we run in Msfvenom, like so, if we just run Msfvenom, we'll realize something, not Msfvenom, but Msfvenom. If you run Msfvenom without any command line arguments or any options per se, you get something like this. Okay, and this is something that we want. Okay, so whenever you using Msfvenom, there's a couple of options that you always have to give. These are compulsory. Okay, otherwise you cannot build a payload for it. Firstly, you need to give a payload type. This is the payload type. What type of payload are you creating? Is it an Android payload? Is it a Windows payload? Is it a PHP? Is it one made for iOS systems or one made for Apple systems? This is where you have to specify the payload type. This is one of the things that you need. Next thing you need is known as the lhost. Lhost is me pretty much specifying per se my IP address. So if we go back to this instance, there is me. The idea of the payload in this case is I'm going to have a payload that's going to go in like a Trojan horse, and then it's supposed to make a hole in the firewall. So it's going to make sort of a breach into the firewall. And this breach in the firewall is what allows me to connect to it. So I need to specify this lhost such that the payload will know where to send the connection request to. Hence, I have to mention the lhost, the local host, the host where this machine has to connect back to, and L port, the port that is going to be connected back to. in this case. So I would want to explain to give the L port, and then lastly it's the output file. Okay, so I need these three things most of the time. There are cases, of course, where I may not per se give any of those, but nonetheless, we're going to try the first example, which is actually provided here. So I'm going to go ahead and say Msfvenom. Okay, and then I'm going to use the P switch. The P switch, remember, is to give the payload type. What's the payload platform? I'm just gonna first list out all the available payloads that I can make. Msfvenom comes with a whole lot of options, and if you just say list as given by the usage there, list, and then you can list which type of module you like. I want to list the payloads that I'm able to build. So that is what I'm doing right now. So we're gonna wait for that to list out all the payloads that we are essentially able to build in this case, and then let's see what we get. All right, beautiful. We got some output. So it took quite a while because it had to really search for all these payloads, but nonetheless, after running the command, we got a total of 1,382 payloads, and that's a whole lot of payloads if you ask me. But nonetheless, all of these payloads, each of them, they have something different that they do, and it's pretty much explained there. But what we want to do now is, let's just propose we'll make a payload for a Windows system. So here's the Windows, there's the CMD Windows. All of these is they just execute an HTTP server. Some of them will open a hole in the firewall to allow us to connect, and so on and so forth. But these are the CMDs. I don't want those ones. I want straight out Windows ones. So I'm gonna scroll through until I get to the Windows section, which is the spot. And there's a specific one I'm going to get, which is the Meterpreter. And what the Meterpreter does is it will open a hole in the firewall. And I want this one that binds the TCP. So I want this one. Of course, I could have gotten the reverse TCP, but I'm just gonna go for a direct connection in this case. Okay. So we've mentioned you have to say Msfvenom, and then use the P switch, and then you're gonna paste the payload type. Remember, once again, after the payload type, we need the local host and the local port. I'm gonna propose that the local host in this case will be, I don't know, maybe line port 9, I mean not 99. Okay, here we have to give the IP address of the attacker. So I'm just gonna propose I'm gonna run ifconfig to get my IP address, and I'm using this for internet access. So I'm gonna propose that I take this IP address in that case there. So I'm just gonna copy that through and then paste this as my local host, and then I'm going to specify the local port. Local port, I'm just gonna use port 99. You can give any port number up to 999. Okay, and then I have to now give the output file. Okay, note now, since it is the output file, I'm going to give the file name that I would like to give to my payload. In this case, I'm just gonna call this file program. Now I have to say .exe because this is a Windows type of a payload. If it was an Android type of a payload, I'd have to say .apk, and so on and so forth. So in this case, it's a .exe file, and then I'm gonna hit enter. And once this has happened, this will take a little while. Perfect. So if we check by means of pwd, we see the location that I am. So what I'm going to do now is just run tunar, which is just going to open a file browser in that location. So here's the file browser that is opened, and we'll see the file program.exe that I have just created. So I'm just going to propose I scan this payload with a antivirus, just for the sake of testing, to actually see if it's going to be detectable by an antivirus. That is all we're going to do. So I'm going to propose I take that program.exe, and then I'm going to scan it through and see if I get any results there. and we're not in good business in this case. That's 11 antiviruses so far. So no, we're not safe. Alright, okay, so we got up to 15 antiviruses that managed to catch that malware that we built. Ooh. Okay, yep. So we got 15 antiviruses that managed to catch it, including the most common, Avast, and my most trusted other antiviruses, like even Google here managed to catch it. So that's quite a lot of antiviruses. So other cases that people may consider is to use an encoder to encrypt the entire script. So let me just stop the file browser. Let me do that. Okay. So I'm going to take the very same script. This is the script that we used, the command that we used to create the file. So now I'm going to propose, I'm going to run Msfvenom first, and I want to list out the encoders that are available. Okay. Remember, the idea of encoding is to take the program that has been created, and then I'm going to lock it up and throw away the key. And if we look at these encoders, we'll see a couple of encoders. And the one that I would like to use is the Shikataganai, a polymorphic XOR feedback encoder. And you can see this is given the ranking of excellent. So I'm going to propose that I use Shikataganai in this case. So I'm going to copy that. And then I'm going to take the very same command that I have used previously. But before giving the output, I'm going to use the E switch to give the encoder, and I'm just going to paste that encoder there. This is just to lock that up. And then I'm going to run this again. This will of course replace the program.exe file that I had just created. And then now we just have a different kind. So this is what we have now. Okay, so it has been encoded, as you can see, with Shikataganai. So I'm now going to go ahead and run an antivirus scan again. Program.exe, like so. And then I'm going to confirm that upload and see if we have any changes to our results from 15. And how much do we have now? So we went down from 15 to 6, from 15 to 11 per se in this case. So we can see the other antiviruses like Avast and the others are no longer able to capture that the malware that we have just created. Others, they're just going to detect it due to the fact that we are using Shikataganai. But yeah, that's the idea. Okay, so using an encoder is of course one way of preventing detection per se. Another way of preventing detection is by writing it in pure source code. What we're going to propose we do is we're going to run Msfvenom, and instead of running this thing by default and going in straight as Windows, we're going to propose that we use a different payload. So I'm going to list out the payloads as I did before, but this time I'm not going to create it as a Windows payload. I'm going to create it as, say, maybe a Ruby payload or a Python payload. The main option and the main idea right now is to write this thing in source code such that the antivirus will detect it as if it was just a source code as it is per se, just like it was a text file. And because it's like a text file, and these antiviruses can't read the code, the source code per se, and understand the source code, they will not detect it. Unlike the case where it has been compiled and everything looks dangerous already. So what I'm going to propose now is, instead of going for Windows, I'm going to go straight into one of these languages. Need it be Python or anything. I'm just going to go for Python in this case. And let me propose I take the Python interpreter bind TCP. Okay. I'm going to go ahead and clear this out. And then propose now. I'm going to use the same command that I have used before. And I'm going to change my payload platform. And I'm going to use this. And I've got everything I'm also going to get rid of the encoder. I may not need it in this case, and you can probably see that I don't need the .exe. I'll need to say .py since this is a Python file, and then I'm gonna let it rip and see if I have any of the differences. Okay, beautiful. So it is done writing. So now I'm gonna propose. Oh, just to make sure, I'm gonna run to now to see if the file has been created. Program.py, and there's our program.py. Perfect. So I'm gonna go back to VirusTotal, and I'm gonna upload the program.py, and let's just see in this case if it is able to be captured by the anti-malware. Alright, so we went down from 11 this time down to 5, which in my defense, I don't know, this seems a little bit better. So let's propose now. I mean, of course, it's a Python file, it won't be able to run. So the remedy after that is to use the py installer, and py installer will change your Python file into an executable file. But anyways, that is medicine for another disease. So here, let me just propose from this. I will change it to use a reverse TCP. Reverse TCPs are there to avoid firewall detection, because firewalls can also detect them as well. I'm gonna propose I use that. And remember, if you would like, of course, you can even go for a step further to use an encoder like the Shikataganai, even while using the Python type of payload. That works as well. Okay, so from 5, how low can we get? Well, we're down to 7 detections. So doesn't seem so bad. So what can we do to even make this even better? Well, maybe we can even use that Shikataganai that we have used, and that's the Shikataganai. So let me just propose I'm gonna copy this, because honestly I'm not gonna cram this. So I'm gonna go down to the one that we have used, which is this, and then propose maybe we'll use an encoder like so. Maybe that helps. Maybe that would help in our anti-malware detection. Now, of course, there are other tools other than using the things that come with Msfvenom. There are other tools that are there to remedy the anti-malware captures, and most of these you would see coming with Kali Linux when you get to the social engineering part. A good tool that I have used before is Unicorn or something like that. But nonetheless, we're going to see some of them in the upcoming week as well when we begin social engineering. Oh, and this seems worse, honestly. So this seems worse. So I'm sure you can see at this point that using this Shikataganai, in most cases it will just be detected. Most of the time it will just be detected. But nonetheless, that is the idea of Trojans and all that. You're probably asking, well, what about the other thing that you mentioned about exploits? Well, this is something that we're going to see from next week when we're looking at the MSF console. The MSF console in this case is the one. Let me just give you a little spoiler of what's coming. MSF console looks something like this. Looks big, of course. It looks really complicated. You can see after I've loaded up my MSF console, I've got up to 2,335 exploits, 1,220 auxiliary modules, this amount of payloads, of course, 46 encoders, 11 hops, and 9 evasions. This is something that comes with the entire Metasploit framework, but this is something we're going to see in more detail. This is the one where we're going to be able to create an exploit to be able to listen out for payloads and do some cool stuff, of course. But this is next week's stuff anyways. So this is it for today on making payloads and detecting payloads as well as evading anti-malware. So I will see you guys in the upcoming week, and remember to make sure that you do submit those 3 assignments out of the week. See you guys.